Oh, wonderful. It happens, doesn't it?
It's
I'll have to bring some in, at least for this class. Hi, Abby. We started by, there was the last assignment that I gave was 2 problems. They were blue, and many of us had cut them out, or actually I gave them as strips, didn't I? Mm-hmm. So we actually taped them into our comp book, and that was before the movie. So we just started number 48, and on number 48 we were drawing a number randomly between 1 and 40. And the problem in part A asks, what's the probability of drawing an even number and then an even number? So we calculate that by multiplying the probabilities like this, and we got 1/4. All right, Molly, read part B.
What are the probabilities that one number is even and one is odd?
All right. So Molly, will that be any different than what we had up here? All right, I thought so too, but then, so this much is correct. So the probability of even is 1/2, and followed by the probability of odd is 1/2. So we get 1/4 initially, but the thing that I forgot as well when I did this is 1 is even and 1 is odd. Does not also include this? You see how that's different? Yet it still meets the requirement. Here we're looking at the probability of the first one being even, the second odd. And the next one, we're looking at the probability of the first one odd and the second one even. Both of those meet the requirement of part B. So here, Miles, we get another 1/2, 1/2.
So is it 1/16?
Actually, now that we have the probability of this occurring and this occurring, we add those probabilities. So 1/4 plus 1/4. And I forgot to check my part A to make sure that randomness was, that we were right. Remember that we are. It is right. So we made the right assumption. So over here, 1/4, parth, 1/4. Does it show up over here on the board? Mm-hmm. Sometimes I go off the camera. All right, so we get 1/2 because of that trickiness right here. So, all right. And is there a part C? Yes. And a D. Okay. There's one for all. Bailey, what's part C? Ask of us.
One number, no, both numbers are less than 30.
Okay, so let me replace this right here. Both numbers are less than 30, so I'll write it like this. Less than 30, and that's not including 30, right?
Right.
And less than 30. So what's the probability of less than 30?
29/40.
29 numbers out of 40, and I'm assuming it goes back to that we can repeat, so then what's the second one?
29/40.
Right, so what we do is multiply that out.
So it's 841/1600.
841?
Yeah.
Alright. Is that reducible? It doesn't look like it. Well, let me check my number. 48. Oh, this is now part C. Alright. Let me check that out. That's what I got. Alright. Alright, read D. Allie, your turn.
D, the same number is chosen twice.
So if we pick a number, then we take that. So there we're sure that we're allowed to take a number, the same number twice, so it becomes clear as we go down the problem. So we want the probability of drawing any number. So what's the probability of drawing any number, Allie?
1/40.
Any number.
Oh, any number?
Yeah.
Oh, it doesn't have to be in the 40?
Pardon?
I thought it had to be within the 40 though.
That's true. Any number within the 40s.
So the probability of going up 1/40.
Not just one, because it doesn't matter. That's if I'm asking you, what's the probability of drawing a 10? That would be 1/40. But on the first draw, you can
that's
get...
40/40.
It is. So is that tricky or what? All right, so the first time we can get any number. So the probability is 1 that we get any number, right? So the first one's no skill at all. But now, Allie, we come down to this. Now, I don't know what number I drew here, but it's back in the pile. And now what's the probability that I will draw that number?
Is that one of
Yes.
Okay.
So isn't that a cool problem? I love that problem. All right. 1 over 40. And that's all there was to number 48. Any questions about A, B, C, or D? All right. All right, now we go over to having boys and girls as children. You need that remade up? I'll take away the bottom here at least. All right, number 53. All right, back to you. Hannah, would you read it again?
Yeah. Assume that the probability of the birth of a child of a particular sex is 50%. In a family with 4 children, what are the possibilities that A, all the children are boys?
Okay, that's good. We'll stop there. Probability of boy, 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 boy. All right, so Hannah, what's the probability at the first birth? What's the probability of a boy?
50%, so 1/2.
And the second birth?
Is it all half?
Yeah, third and fourth. But now we multiply together to get the probability of getting 4 boys, one after another. So 1/2, 2 times 2 is 4, times 2 is 8, 1/16. Not a big probability. Anyone know a family with 4 boys?
Yes.
Yeah, so let's look at the odds of that happening. Not impossible, but not likely.
The
All right.
Browns?
Yeah.
Yeah,
Do they have 4?
they have 3. I know a lot of families with 3 boys, but I
But they're
don't know.
having a girl now. And
Oh.
there's 3 boys and now a girl.
All right, so then, all right, Molly, would you read part B?
Sure.
Once you get that down.
Probability that all the children are the same size.
Right. So that means it's sort of like that one I erased because there's 2 possibilities. So do we not have to do the probability of all girls and then the probability of all boys and then add them? Remember that was sort of like the one in number 48 where we had to mess with something. I forget what it was now. All right. Oh yeah, it was even odd and then odd even, that one. All right, so Molly, what's the probability of doing, let's do it this way. What's the probability, if we want them to be the same, I thought of it also this way. If we want them all to be the same, what's the probability of having a boy or a girl the first time?
1.
Right.
That's
So,
how I would. That's how
all
I
right.
thought of
I think
doing it.
it'll come out the same, but let's do it your way.
It'll be 1, and then it'll be 1/2, 1/2, 1/2.
All right.
That's what I did.
So then that comes up to be 1/8, and that's right. And you see, if you do it the way I was thinking, all girls and all boys, you get 1/16 plus 1/16, which is the same. So either way. All right. Part C. Is there a part C? All right. Read that one, Bailey.
There is at least one boy.
At least. So that means 1 boy or 2 boys or 3 boys or 4 boys.
That's not what I did.
That's what it means though, am I right?
I know.
To have at least 1 boy out of 4, that means you have 1 or 2 or 3 or 4.
I did it as it would just be half. Because I did it as the probability of getting a boy, and then the probability of a boy or a girl, or a boy or a girl, or a boy or a girl, and then it would just be a half.
And what'd you say the first one was? 1/2?
Yeah.
That would have been the same as the last one, which would have been 1/8.
No, it would be the probability of having a boy, which would be 50%, would be half. Then the probability of having a boy or a girl 3 times, which would just be 1 every single time, so it would just be a half.
Oh, gotcha. Okay.
But I could be completely off base, and I probably
All right.
So the inverse of that.
The way I did it,
Is
then
it-
we'll talk
yes.
about your way, Hannah, is, remember that day I talked about compliments? And remember I gave you a compliment? I forget what compliment I gave you. But the opposite, what's the opposite of this? what is the, if this does not occur, what has occurred?
Girls. Instead.
What has occurred if this does not occur? Think that one out.
All girls.
All girls. Do you see what Allie said?
It's
So it's one
that's so
minus-
great.
So if we can find the probability of all girls, then we subtract it from what? What did I teach that day?
1.
1, remember? So let's try it that way and see if it comes up to Hannah's answer. So the probability of all girls, I think, is 1/2 times 1/2 times 1/2 times 1/2 is 1/16. So 1 minus 1/16 equals 15/16. So let's try. Hannah, you said on the first birth, the probability of getting a boy was 1/2.
But that's not right.
And what's the probability after having a boy of getting another boy? I think the problem with yours is the or. Like you're coming up with the probability of 4 boys basically. But we have to add to that the probability of 3 boys and the probability of 2 boys and the probability of 1 boy. So it's almost easier to think the opposite way on this one. What is occurring if this does not? It's all girls. That's an easy one. And just subtract it from 1. All right. We can say goodbye to probability. I think you guys are pretty strong on it. It always says it's little, each problem is new. So that's always a challenge, but I have confidence in you. All right, have I blabbed for 10 minutes? Why don't you shut it down?
Okay.
And we'll pick it up in a second.